Good afternoon, everyone. And yes, Mel, I hope you can hear me. Oh, perfect. You can hear me. Great. Thank you all for joining. We have a few people who are still joining us, but I will get started as we are right at time. So welcome, everyone. My name is Mary-Eleanor Power, and I am the Director of Marketing Communications with Dalhousie University's College of Continuing Education. I'd like to begin by acknowledging that Dalhousie University is located in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq. We are all treaty people. Thank you for joining us for today's webinar, Introduction to Lean Six Sigma. We hope you'll enjoy the next hour. And if you have any questions throughout, please add them to the chat, and just make sure that in the chat function, you are just including that you want your question to be seen by all panelists and attendees. So you can see that in the drop down just above where you would type your message. We'll save about 15 minutes at the end to address any questions that come up. And now I'd like to introduce you to our host and one of our instructors, our instructor of the Lean Six Sigma course, Angela Scammell. Angela has 30 years experience designing and facilitating organization development initiatives and training in private, public, consulting, and academic organizations. As a General Electric trained Six Sigma Black Belt, she has significant project management and change management experience and a suite of skills in business process improvement, qualitative and quantitative research and analysis. Angela teaches the Lean Six Sigma Green Belt program at Dalhousie University and also teaches courses in Dalhousie's Quality Management Certificate program. So now, without further ado, I will pass it over to Angela to walk us through today's webinar. Thank you, Angela.
Welcome, everyone. I'm so glad you were able to make time to come today. I look forward to sharing some information about Lean Six Sigma with you, and as I'm sure you will sooner rather than later, I can get very passionate about it. So I'm hoping that you'll actually be a little bit passionate about this. I am curious about why some of you may have chosen to spend part of your Sunday Friday afternoon with me here learning about Six Sigma. If you could type a few words in the chat to let me know, Mary Ellen will share some of those responses.
Perhaps you can repeat the question, Angela. There was just an issue with, on my end, just an issue with audio.
Sure.
Okay,
I'm
great.
wondering why you may have chosen to spend part of a sunny Friday afternoon with me learning about Lean Six Sigma. Just curious about why now, why today's mind. What did that caused you to decide to sign up for today's webinar? If you type that in the chat, that would be terrific. Just have to be a few words. I've heard Lean Six Sigma many times, but I don't know what it is. You are far from alone in that. Anybody else? I think I'll take that as a sign to get on with it. What do you think, Mary Ellen?
Sure.
All
Do
right.
it.
So let's take a look. Oh, there's another comment. What is it?
Have an interest in learning.
I need to learn about project management. I have an interest in learning how it can be applied to healthcare teams. Terrific. To improve patient support. Well, we can talk about some of those things today. We can talk about them further in the questions afterwards. And I will do my best to remember to insert a healthcare example along the way, so that might be useful as well. What we're going to do today is learn a little bit about the core Lean Six Sigma concepts, how a Lean Six Sigma project works, because projects are the driving force between how things get changed and done in Lean Six Sigma. So we'll take a look at what happens in a typical project. I'd like to share a tool with you that can help you recognize the symptoms of a broken process in your own organization, or perhaps an organization that you're a customer of and maybe feeling a little bit frustrated with. Consider the advantages of Lean Six Sigma for you and your customers, and also at the end, to know how to access some upcoming training and resources. When we think about customers, whether they're customers of our whole organization or customers of our department within an organization, most customers, most people, when we're in the customer role, are looking for three things. We're looking for quality, we're looking for speed, and we're looking for a cost that we think is reasonable for what we're getting. And there's a joke that really what customers want is something that's perfect, instant, and free. And I think sometimes we don't ask customers exactly what they want because we're free and they tell us unrealistic things such as free and now and perfect. That said, when customers tell us what they want, it's really important for us to understand that, because the first order of business in Lean Six Sigma is to understand exactly what customers are looking for when they come to us. Sorry, my slides are jumping around a bit. There we go. So if we use a coffee shop as an example, we could say that on the quality side, okay, my computer seems to be doing things that I'm not in control of. I apologize for this. Are you able to see my screen?
Yes.
Okie dokie.
I
Let's
can see it.
I apologize for this, and if it happens again, we'll just roll with it. So if we use a coffee shop as an example of an organization for which customers have expectations, we might say that on the quality side, customers are looking for fresh coffee and friendly service. For speed, we're looking for a reasonable time to get our coffee, because if you're like me, when you're waiting for caffeine, you may not have the most patience in the world. And on the cost side, we're looking for something that we think is reasonably priced. Now, just for a moment, I'd like you to think about, in your own mind, what's the price of a good cup of coffee? Just get a dollar value in your head. You have one? Let's go to the next slide. Hold that thought for a moment. I'm going to do something now that might seem like a little bit odd, but the point will come back to us. When we say words, we assume that other people understand what we mean, and we assume that they think the same version of their understanding that we have, but that's not always the case. Now, I know all of you know what the color blue looks like, and I know that all of you know what a shirt is. So I'm going to ask you to count the number of blue shirts on this slide, and Mary-Ellen will post a poll for you where you can click the number of blue shirts that you see on this slide. So Mary-Ellen, can you get the poll going?
Yes.
Thank you.
Everyone should see it there.
Are people able to see all the shirts? So I hope each of you will click a number between 1 and 10 that shares with the group how many blue shirts you see.
We have 50% of people who have voted, so get your vote in and we'll close it off in another few seconds. Two more people to go. One more. Okay. We'll end the poll there.
So what are our results, Mary-Ellen? Oh my. So when you look at the results, can everyone see the results, Mary-Ellen?
I think so, yeah.
Perfect.
Yes, everyone can, yeah.
So if we're all expert at understanding what the color blue is, and we're all expert at understanding what a shirt is, it's rather curious that we have so many different opinions about how many blue shirts are on this page. And it speaks to the role of assumptions that we have when we're talking and listening to other people, and in particular our customers. Sometimes when we're inside an organization, we assume we understand what our customers want. And if we were understanding that they wanted blue shirts, in this case, We can't decide whether we have 4 blue shirts to give them or 10 blue shirts to give them, or some number in between those things. So I hope this is a fun way of realizing or seeing for ourselves that when people talk about their expectations, sometimes the clarity is not as great as we think it is. Now, let's go back to that cup of coffee. I asked you to consider how much a good cup of coffee should cost. Well, not only does that depend on your perception of a good cup of coffee, it also depends on where you might want to get that cup of coffee from. So when we think about Tim Hortons and Starbucks as providing quality coffee, and quality being measured by freshness, at Tim Hortons, they provide a 20-minute or less guarantee, whereas at Starbucks, it's not fresh unless it's made to order. We call both of those things fresh, but they're very different than one another. With speed, we're looking at a difference between 30 seconds to get that caffeine in your hand, or up to 5 minutes to have a latte made. At Tim Hortons, we might expect to pay about $2 for a cup of coffee, and we might be horrified to think that a cup of Tim's coffee could ever cost $6. But at Starbucks, that's far more the norm. Now, is one of these sets of definitions right or wrong? No, they're just very different. And the key to success is knowing exactly what our customers expect from us. And the key to that is to really ask the customer. So one thing that we do in Lean Six Sigma right up front is we ask our customers to define numerically as much as possible what exactly do they want, so that we can be clear about our intention to provide exactly what the customer needs. And there's different methods of doing that. Now, if we want to reliably give customers what they want, we need to develop and run processes that allow us to do that. And a process is merely a combination of inputs, such as the ones that you see on the screen over on the left-hand side. There's work effort, information, knowledge, time, energy, money, materials. We take those inputs, we do things to them called activities, and our output is what you see over on the right-hand side. It might be a product. It might actually be a service. It might be a transaction, such as a payment. It might be creating a decision, hopefully a correct decision. We also often produce things that are in addition to the main thing we're hoping to produce, such as records or waste. And our goal with processes in a Lean Six Sigma organization is to design processes that are really effective at reliably giving the customer exactly what they want at the customer's definition over and over and over again, every time the customer asks. And there's an art and a science to figuring out exactly how to do that. In most organizations, if we ask if our processes are reliable and efficient, there are really 3 different sets of answers that you might get depending on your perspective. One thing that we think about when we think about processes is, what do we think is actually going on? If I asked you, have your organization created an invoice? You probably have an idea of a set of steps. Or if I asked you, what are the steps involved in moving a patient in a hospital from the 2nd floor to the 4th floor? You would likely have a high-level understanding of that, and you'd be able to list the steps that you think is in that process. And that's represented by this diagram over on the left-hand side. However, if I were to gather the people in your organization who actually do that task and ask them, what does it really take to get it done? Oftentimes, everyone in the room is surprised to find out that the process is actually much bigger and perhaps clunkier, less efficient than it sort of should be. So we think it looks like the diagram on the left, when in actual fact, it looks a lot more like the diagram in the middle. And only the people who work in that process know what it actually takes to get that process done. And only the people who work in a certain step understand the steps that are required to actually make that part of the process done. So it's rare that one person knows exactly what happens from the time the process begins to the time the process ends. Now, over on the right-hand side is the gold standard of what we'd all like it to be. We walk into a coffee shop and we say, I'd like coffee, and someone hands you your coffee, and then you say goodbye. This is what we all shoot for, and rarely is a process ever that simple. But with Lean Six Sigma, we look to understand this middle version of the process. What does it actually look like, lumps and all? And how can we make it look a lot more like this so that it's efficient and reliable and always produces exactly what the customer wants? Because what we think of as employee mistakes are often caused by poorly designed processes that are kind of designed to fail. They have a lot of risk embedded in them. And so employees who are trying their best have a really tough time sometimes of doing things the way that they've been asked to, because the way they've been asked to do it, or the way that they've inherited the procedure from their predecessor, has more risk and opportunity for mistakes built into it than we wish it did. I see a chat question. Mary-Eleanor, are you keeping an eye on chat, and will you let me know if there's something I need to respond to?
Yes, it was just a comment, just emphasizing that it was a really important point that employee mistakes are actually process issues. So not a question, more of an emphasis.
Absolutely. And in Lean Six Sigma, one of the phrases that you'll hear over and over again is, it's not the people, it's the process. Don't fix the people, fix the process. Every once in a while, an employee will find themselves in a role that they're not well suited to. So rarely, it might be a mismatch between a person and the task that they are attempting to do, or the job that they're attempting to fill. But way more often than not, it's because the process has risk. So thank you for backing me up, whoever made that comment. I appreciate it. This diagram is of a target, and I'd like you to think that the bullseye center of the target is all about giving the customer exactly what they want. And the further we get away from that target, the less happy the customer is. And once we get outside those bars that go up the side, you might recognize this as a football goalpost. Once we're outside of that goalpost, the customer isn't happy anymore. Now, this diagram starts off simple and it gets a little busier, but we'll go through it together. So our customer might have a standard for something that we're producing, such as a baseball. They might need their baseball to be a certain specific size that's represented by the center of the target. If we make a baseball that's exactly the right size and weight, we have hit the target. But some baseballs are too small. Some baseballs are too large. And if it gets bigger than a certain size, the team can't use it. If it's smaller than a certain size, the team can't use it. So we have to understand exactly what the customer wants so that we can define what's too small or what's too large. With our cup of coffee, it could be too cold or it could be too hot. There is a perfect coffee temperature in the customer's mind, and we need to know what that is. We could do things too early. We could do things too late. An example of that might be asking the cable company to come hook up cable in your home. Do they show up when they say they're going to show up? Do they show up too early? Do they show up too late? So if they tell you there's a 2-hour window, do they show up within that 2-hour window or inside the goalpost, or do they show up too early, too late, messing up your day? Is something done too quickly or too slowly in order to get it right? So think about, for example, baking a cake. If you leave it in too long, it's going to burn. If you don't leave it in long enough, it's not going to be very tasty. If we're putting a coating on something, is it too thick? Is it too thin? When we hit the target, and when we hit the target over and over again, let's use a cup of coffee for our example. If we're trying to make a cup of coffee that is the perfect temperature, ideally, we have a process that results in a perfect cup of coffee, the perfect temperature every single time. And that's what this green box represents. No matter which employees are doing the task, they get it right every single time because the process is so well designed, it's really tough to fail. That's what we try to get to design in Lean Six Sigma. Unfortunately, not all organizations operate that way. Sometimes we get more variation in the temperature of our cup of coffee. So it might be hotter than we would like, or it might be colder than we would like, but it's still inside the goalpost. It's still inside the allowable range. So the customer's pretty happy most of the time, but perhaps not quite as happy as if when it's the perfect temperature. These situations that we've just looked at are still okay. They're pretty good. But what happens if our coffee only has a moderate amount of variation in temperature, but it's almost, a lot of the time it's too hot? We're going to start losing some customers. Our customers are going to start getting frustrated. Frustrated customers either just leave, or sometimes they take the time to tell employees about their dissatisfaction. And I think we've all probably been both on the receiving end of those comments and perhaps even on the giving end, if we're being honest. Customers aren't happy all of the time. And when our processes are not designed to give the customer exactly what they want, we get a lot of complaints and frustration. So it's bad for customers, it's bad for shareholders because customers leave, and it's bad for employees who have to listen to a lot of complaining and may feel helpless about how to give the customer what they want. And then there's the worst case scenario where the coffee can be ice cold, it can be scalding hot, and customers never know what they're going to get. Employees never know exactly what they're going to give the customer. Those are the worst processes. And what we find in many organizations that I've had the opportunity to work with, sometimes this happens, especially if formal process improvement efforts have never had the opportunity to be applied to the organization's processes before. So it's not abnormal for this to happen. But this is what we're looking for, and Lean Six Sigma is fantastic at helping organizations figure out how to reliably give the customer what they want over and over again, regardless of which employees are on the job. If you remember one thing from this webinar about Lean Six Sigma, what I want you to remember is that too much variation is bad. It costs money, it causes frustration. Here you can see that the car is small enough to get through the door, but somebody veered way too far to the left. That's just like what happens when our coffee is always too cold or always too hot. It costs time, money, and frustration. Variation is very bad. And the Six Sigma part of Lean Six Sigma is really good at finding out why variation happens and eliminating it. We talk about Six Sigma quality. It is actually a numerical thing. And what we're measuring with those numbers is this. If you were to try to make something or do something 1,000,000 times, how many times would you get it right versus how many times would you get it wrong? So if we're thinking about pouring a 1,000,000 cups of coffee at Tim Hortons, if we were at a 1 Sigma level of coffee, we would have 347,000 of those 1,000,000 cups of coffee be at the wrong temperature. So 1 Sigma quality is not very good. And I can tell you, the worst project I ever worked on, or the worst level of quality I've encountered, was actually minus 1.21 Sigma level of quality. So if this is 1 Sigma and 1/3 of the items are being produced incorrectly, you can imagine how bad a -1 Sigma process was. It was pretty bad. And really, Six Sigma just gives you the tools to fix it. At a 2 Sigma level of quality, we go all the way down from 347,000 cold cups of coffee to 45,000. And you can see as the level of Sigma goes up, the number of mistakes per 1,000,000 tries goes down exponentially. By the time we get to 6 Sigma level of quality, we make a cup of coffee that is too hot or too cold only 0.002 times out of 1,000,000. So you'd have to make about 10,000,000 cups of coffee in order to get one at the wrong temperature. So that's what Six Sigma quality strives for in an organization. Now, Some of you might be interested to know that there is actually a cost relationship between how many mistakes get made and the money the organization needs to spend unnecessarily to find those mistakes, prevent those mistakes, pay for the waste that comes from them, or the scrap that comes from them, to pay for quality inspectors, to pay for warranty claims, to pay for insurance claims. We can define this in general is at a 2 Sigma level of quality. 50% of your organization's revenue or budget is being spent on fixing problems, which is rather shocking. Most organizations won't stay in business very long at that rate. Now, at a 6 Sigma level of quality, only 1.5% of revenue goes towards quality costs. And what happens with the remaining revenue? It can be reinvested in the business, it can be shared with shareholders, it can be used to lower prices, all kinds of things that benefit people, as opposed to spending money on the frustration and delays and costs of not getting it right the first time when we aim to give customers what they want. Mary-Eleanor, I saw that there was a comment. Are you able to share that with the group, or is it something that is not for sharing?
No, absolutely. I was just about to jump in. Just someone asking in the chat here, can you elaborate? I believe I'm interpreting this correctly. Just elaborate on the value of defects per million if just you made reference to the negative value of 1.21, I believe it was, and what the defects per million would be roughly for that negative signal.
I can't recall what the defects per million are exactly, but I can estimate it. And the defects per million, sorry, I'm just jumping around there, at negative 1.21 Sigma. That organization was getting more wrong than they were getting right. More than 50% of the occasions to do a task, they were not meeting standards. And I can tell you what the topic was. It was actually a project for hiring new staff. And there is a part of that process that is all about writing the job description, updating the job description. And for this organization, the process ended when the job description was posted. From the time that the manager started writing the job description and getting it approved to the time that it was posted, there was a standard that said it should take 20 days at the most. And in this organization, the average was actually closer to 60 days. And since that's the average, that means half of the job postings were taking longer than 60 days, which is kind of mind-blowing. So the maximum was supposed to be 20, but the average was 60. And over half of them, well over half of them, were late beyond that 20-day limit. I hope that answers the question. As a cost of quality, there is a cost to your organization of not getting those job descriptions posted on time or getting people hired, new employees hired on time. There's an opportunity cost to being short-staffed, as you know, just like there's an opportunity cost to producing bad cups of coffee, because then you have to replace the customer's cup of coffee, and you have to rebuild a relationship with the customer when you've let them down a number of times. So these costs are summarized in this table, and as you can see, if you invest money in preventing mistakes and delays, it actually pays off on your bottom line. You will save more money. You will have a better profit margin by preventing mistakes than you will by catching them and reworking them before a customer has a chance to find out about them. So, given the numbers I just showed you, what are a couple of practical examples of Six Sigma quality? Well, if you were reading a book and there were typographical errors in the book, and the book was written at a 4 Sigma level of quality, now remember 4 is not as good as 6, but 4 is really good, you would find that there was one typo every 30 pages in the book. And as you can imagine, It wouldn't be the worst written book in the world, but you would still probably notice it and wish that there weren't so many typos. But it's not that bad. It's reasonable, I guess. But at a Six Sigma level of quality, how many typos would there be in a book? If the book was written at a Six Sigma level of spelling, it would be one word misspelled in an entire small library full of books. So you can see, even though 4 Sigma sounds pretty good, the jump to 6 Sigma is extraordinary. It's wonderful. Now, I do have a healthcare example coming up. If the patients that went missing at a medium-sized hospital was converted to Sigma level. Now, you may know, in some hospitals, they do have trouble. One concern is that sometimes patients go missing. They can't be found in the system either through an error in the database or perhaps because the patient has wandered off. And the hospital that was used as the basis for this was the Ottawa Hospital. So if we look at the number of missing patients at a 1 Sigma level of quality, in other words, if the hospital was not very good at keeping track of its patients, 3.5 patients per hour would go missing. I'm not saying that this actually happens. I hope it really doesn't. But if the hospital was managing that issue at a 1 Sigma level of quality, 3.5 patients per hour, and you can imagine the money, frustration, risk, fear, you can imagine the costs of that kind of a situation. At 2 Sigma, it would only be 1.5 per hour, substantially better, but not really, as far as clients are concerned, as far as the public's concerned. When you get to 4 Sigma, you'd have 5 per week. At 5 Sigma, it would be 10 per year, but at 6 Sigma, it's 1 every 7 years. So you can see I hope this example helps to show why it's really worth investing the effort and time into improving quality, because when you improve quality, often will improve speed and cost at the same time. You might think that if quality goes up, speed goes down and costs go up. It does not work that way. In a Lean Six Sigma project, typically what happens is that as you improve quality, you also improve speed and reduce costs. And I know that sounds like magical unicorn talk, but I promise you it happens. And it's just phenomenal to watch that in action when you're leading a project and you see how employees and clients alike respond to a drastic change, a drastic improvement. It's just the most gratifying feeling in the whole world. Now, why am I telling you this? Most organizations are really good at what they do. Customers like them. They tend to, feel pretty good about them. Most organizations actually that are really considered to be pretty good are operating at about a 4.5 Sigma level. Organizations that customers think are pretty bad are generally 4 and less. If your organization has committed people, smart people who work really hard at improving quality, but they don't have Lean Six Sigma, research shows that most of those organizations can get to about a 4.5 level of quality through hard work, perseverance, and commitment. But when those organizations are offered the Six Sigma toolkit, the Lean Six Sigma toolkit, that's what can take them above that 4.5 level and into 5, 6, which is where huge customer loyalty is generated. Now, I'm talking like this is a company that's doing this with its external clients. I want you to also consider that it's one department that supports another department and do this as well. I see another comment. Mary-Eleanor, will you share?
Yes. Happy to. So the question is, how big does the institution have to be for us to be able to apply the level? As an example, would it be able to be applied to a clinic with 200 patients and maybe 4 healthcare providers?
Absolutely, 100%. I know that when we talk about millions, it sounds like, oh, this wouldn't be useful in a small organization. That is not exactly the truth, because we can take data about your 4 team members and the results that they achieve in your institution that has about 200 patients. And we'll use statistical analysis to take the information that you have to better understand how that process would work at bigger levels. And it's not a simple measure of extrapolation. There are technical statistical tools that can help you understand how well your organization's performing, even if you don't have a huge amount of cups of coffee or patients or transactions. And I also want to let you know that when I start talking about statistics, some people will feel a little shiver run down their spine. I want to let you know that all of the statistical analysis that's done in Lean Six Sigma is done using software. So if you don't see yourself as a math person, it's still very doable to apply Six Sigma to your situation. In fact, in the program that we offer at Dal, the Lean Six Sigma program we offer at Dal, we provide you with a copy of the software for free while you're taking our program. So if you don't see yourself as a math person, no need to be nervous, because we've got your back. I'll continue moving on, but if any of you have any comments or questions, feel free to pose them, and I'll make sure that Mary-Ellen and I give you the answers you're looking for. So, how do we do all this magical stuff? Well, what we do is we set up a project using a methodology that is nicknamed DMAIC. And DMAIC stands for Define, Measure, Analyze, Improve, Control. And in a moment, I'm going to show you some of the key activities that happen in a DMAIC project. I won't show you all of them or all of the tools that are in there. Come to the course and we'd be happy to share them with you. But we will give you an idea of the key things that happen at each of these project phases. Now, at the define phase, the most important thing to do is to scope the project so we understand what we're really trying to change, and we understand what it is the customers want. What are the customers' goalposts? So if we're trying to improve the temperature of our coffee, what do customers say is too cold? What do they say is too hot? What do they say is ideal? We need to understand that from the customer's point of view. And we also need to take into consideration legal requirements, organization policy, employee consideration to make sure that we are treating people well, both inside the organization and out. We define the problem that we want to solve, and we define what the customer's looking for with respect to that problem. And we make sure that the projects we choose are linked to the strategic goals of the organization, because we want our time and effort to be spent on things that will pay off in terms of the organization becoming the kind of organization with the kind of customer support that we want it to become. At the measure phase, this is where we get the numbers. Some organizations already keep spreadsheets full of numbers that talk about how well they do or where they need trouble, or they measure how long something takes. Some organizations don't have that, and depending on where your organization is starting from, we create a strategy to get the information we need, the data that we need to understand how does this process actually work? What are the steps in it? And where are the trouble spots in it? And we use, as I'll talk a little bit about later, Six Sigma is rather unique in that it has a robust way of dealing with numerical data, quantitative data, but it also has a very robust toolkit for dealing with employee expertise, knowledge, insights. It's a way to bring those two worlds together, and that is what makes it so powerful. That's why it's very difficult for organizations that don't have this methodology to achieve results beyond about the 4.5 Sigma level, because you really need the power of employee insight, knowledge, and an innate respect for what employees bring to the table, matched with the secrets that are hidden in your data that statistics can help reveal. At the analyze stage, we find those relationships, and the really cool thing is that we can often boil down why are our cups of coffee too cold or too hot. We can often take 30 potential reasons and boil it down to one, two, or three reasons that we know for sure. And that is really thrilling stuff when that happens. We can prove it. Then our improvement efforts for fixing that process so that it reliably gives customers what it wants. We only have to focus on improving a small number of root causes that we are assured are the correct root causes. So Six Sigma projects don't spin their wheels as often as non-Six Sigma projects because we're not guessing that we've got the right cause. We pretty much know it. We can pretty much prove it through the use of employee now file blended with data and statistical analysis. Another thing I really like about Six Sigma projects that's different from others is the control phase. And at the control phase, we ask the question, how do we prevent backsliding? How can we make sure that this new improved process that really works is maintained once the project is over and the manager or the director, whoever's in charge of that process, takes it back again and we go back to business as usual? How do we make sure that those changes are sustained? And that is kind of what happens in a Six Sigma project. I'll show you a couple snippets of what that might look like. One thing that we do is we map processes. Now, you might recall a little while ago I showed you 3 versions of a process, what we think it is, what it really is, and it might be really bad, and what we'd like it to be. One thing that happens when we map processes, we get people in the room who actually do the work, and we say, please tell me what it really takes to get your job done. We might have a process that we think is only 3 steps long, and you'll see that in the green text on your screen. We have step 1, step 2, and then we deliver it to the customer. 3-step process. But people in your organization are saying, if it's these 3 simple steps, why does it take so long? Or how come they're not done right? Or how come it costs so much? When we take a closer look at the process, we might find something that looks like this. Oh, after step 1, we have to inspect it to make sure that it's right. And then oftentimes, maybe even 50% of the time, we find out there was a problem and we have to correct it. So imagine if you're in a department that produces invoices. Let's say we put down all the costs, but then we have to check it and see if it's right. If it's not right, we have to figure out what the problem is and then reproduce the invoice. What we've actually done is we've taken step 1 and turned it into 4 steps. And I've shown the same pattern again at step 2. So what we think is a 3-step process, we might find out when we map it that it's a lot longer, a lot more complex, and that can explain the extra time that it takes and the extra cost and a lot of the frustration that gets generated, both for employees and for customers. Now, I'm going to warn you, this one's a little tricky. We also measure each step of the process, and it's not as painful as it sounds. We measure at each step of the process to say, is that step working as fast as we need it to? Or is the quality as good as we need it to be? Okay, so time, cost, and effort, and quality. So let's say we have a 5-step process and then we deliver it to the customer. And let's say we do some measurement and we see, oh, wow, step 1, 95% of the time, the person who does step 1 gets it right. At step 2, 95%. And 3, 4, and 5 are as high as 90. That sounds like a really great process. And I'm going to ask if you're a brave soul, if you will go into the chat and write down what level of quality you think the customer probably gets. What's the ballpark level of quality the customer probably receives if each of the steps are being done at 90 to 95% perfection? So just throw a number into the chat and Mary-Eleanor will tell us some of the numbers that she sees.
I was going to say 3.
3% perfection?
Or 3. Oh, well, I was thinking of the same as one of our participants, 4. He was saying 4. They were saying 4 sigma.
Oh, you're thinking sigma level.
Yeah, that's what I was thinking.
Totally get it. See, you guys are more Six Sigma than I am. 3%. Terrific. So 4 sigma, which would be in the ballpark of about 90%. I see some other numbers in there.
I was going to say 3 sigma, yeah. 92%, 75%, 60%.
Oh my goodness.
Someone's saying 3 sigma.
Quite a range, isn't there?
80%.
Awesome. And you can see that, you know, on a ballpark, it looks like it's pretty good. But I want to show you how this really works. And there's some sad news in there. And I think a couple of you are in on the secret already of how this works. What we need to do is not just take an average of how well we perform at each of these 5 steps, which would put us at that 4 sigma level or 92% level. That's what it would do. What we have to think about instead is this. Let's say we're producing invoices, and at step 1, 95% of our invoices were completed correctly up to that point. And at step 2, this person adds some information to the invoice. Well, 95% of what they add is correct. So we have to take 95% of this 95% to find out what the resulting level of quality is. So 9 times 9 is 81, so 0.95 times 0.95, we're in the 83% range. And it can only go down from there, because if we don't get 100% perfection, even after these 2 steps, the best we can do is about 80%. And whether the math is your friend or you're not, don't worry, we've got software for all of this, and far more complicated math than that, but the software will do it all. In fact, what winds up at the customer's door is only 66%, or only 66% of what we send out will meet customer expectations. And inside the organization, we can be mystified by that. Because all the people in the process who have their boss maybe wagging their finger at them and saying, you guys need to do better, they're saying, but I'm doing 95%. You know, this is fantastic. I'm not the one creating the problem. But the problem doesn't lie generally in what one person does. It lies in the risk of mistakes or delays that's built into the way the process is designed, and by the fact that processes have a number of steps that have to work interconnectedly. And what we've learned to do in Six Sigma, Lean Six Sigma, is build processes where that interconnection works beautifully instead of causing us more risk and more damage. So I hope that didn't seem like a bit too much of a setup. A couple of you, when you were saying 60 and 70%, you may already know how this works. But to the fresh eye, it really does look like 90-95%. That's what I thought the first time I was looking at this. And as you can imagine, the longer a process is, and many of the processes that I see in organizations I work with are anywhere from 60 to 120 steps long. The longer this process, your process is, the more there is a need to be pretty much perfect at each step. So we do this in a project, and you'll have tools for that that make it a very straightforward, easy to perform process. We set a project goal. If our process to make coffee at a certain temperature is not very good, it only works at 3 sigma. We set a project goal to reduce 90% of the defects, 90% of the cups of coffee that are too hot or too cold. And that may sound like a shocking number. I can tell you the Six Sigma Toolkit is fantastic at helping you do just that. It's wonderful. And if the process is already pretty good, we're going to get 50% of the remaining defects out of the process. And those are very reasonable expectations for you and your team members to have. It's really quite phenomenal. And the best part is you can prove you did it when you're done. At the analysis stage, as I was mentioning before, we combine what employees know better than anyone else with statistical analysis. And Lean Six Sigma has really figured out how to make that work. So it's not just employees brainstorming. It's not just somebody sitting in front of a computer crunching numbers. It's putting those 2 things together so that by the time we analyze the causes, we can boil it down to 2 or 3 things that really matter, and we can prove it. And that's pretty powerful stuff. We also take a look at the process and say, where are employees doing things that cause human beings to make mistakes? And these are called error-provoking conditions. There are certain working conditions that just lend themselves to people making mistakes. There are 12 of them that we deal with in our program. I've shown a few of them here. For example, having to do something over and over very quickly. That causes people to be more likely to make mistakes. The thing that you might not know is that there are actual strategies that you can build into your processes to reduce the amount of mistakes, to prevent mistakes that are making through rapid repetition. And the same with the rest of these things. We also look for 8 different types of waste. And waste is the opposite of what we call value added work. Something is value added if the customer wants it and is willing to pay for it or wait for it or invest in it. And the kinds of waste that we identify and remove from processes allows our processes to be operated at lower cost and faster speed while delivering the essential core desired quality that customers are saying that they're looking for. So we learn how to get waste out so that we can keep that process operating between the goalposts. So there are 8 wastes, and kind of a fun fact is that if you organize them in this order and you look at the first letter of each word, it spells downtime. So we're trying to reduce downtime from our process. And when we reduce downtime, it makes the process cheaper as well. Now, I'm going to pass by this. Once we have improved our process, we want to lock it down. We want to control it. So I was mentioning a few moments ago, we want to make it sustainable to reduce the likelihood that people can make mistakes over the long run. And I've got a few famous mistake-proofing tools on my chart here. I'll start with the hospital-related one because anyone who's ever been at the emergency room at any of the hospitals will probably have seen this one before, even if you don't recognize it off the top. There are different kinds of gases that are commonly needed in hospital rooms, and they are nitrous oxide, air, vacuum, which is the opposite of giving someone air, and something that all of a sudden I can't read. Oh, oxygen, sorry about that. And can you imagine how devastating it would be if you try to give someone medical air and you wind up giving them vacuuming by accident? It would not go well. So when you look at the hookups where the hoses connect to these 4 input valves, you'll see that there are different settings, different places where the little holes are. There's a different shape. So it becomes impossible to put the wrong hose or to put a hose in the wrong place. You'll also notice that they're color coded, which helps a medical professional who's maybe working in a stressful time or trying to do things quickly. It also helps them to get it right. Checklists, another mistake-proofing tool. Airline pilots use them all the time to make sure that they don't overlook an important step and to make sure that everything's done completely. Drop-down lists are another office-based type of error-proofing tool where if you don't want people to type things in and to type in things that they shouldn't be typing in, we offer them a range of options that they can select from. In this example, you'll see that there is a bucket of bolts down here and they get stacked on top of one another. You'll notice that this section of the bar is orange, and the operating rule is if you can see an orange bar, it's time to order some more buckets of bolts so that it prevents us from running out. Now, I'm not going to ask how many people know what this is or perhaps have ever operated one in their lives. This is the famous McDonald's French fry scoop that makes sure that the perfect number of French fries are scooped every single time so that all the serving sizes are the same. And this is a tool board that has styrofoam in it with a shape for each tool, so it's very easy to see if something's missing. And this way we can guarantee that people always have their tools available at their fingertips. So these are different examples in an office world or service world or a manufacturing world or even a food service world or healthcare where we can make sure that the benefits of our improvement project are going to last. And there's other types of mistake proofing as well. Standard operating procedures, for example. So what I want you to know is that as a takeaway, what's coming to you is a checklist that you can use to determine whether your processes are broken. And what I encourage you to do is to read through the 14 different symptoms of a broken process. Think about the process that you spend a lot of your time in and ask yourself if these symptoms are in place. Now, I love this photograph. It's a little terrifying, isn't it? It is actually a real photograph taken in Canada in 2012. It is not Photoshop. There really was this telephone pole or utility pole in the middle of the road, and it lasted for 3 months. That's a sign of a broken process, if you ask me. Another sign of a broken process is some things just take too long and we're not sure why, or things don't get done right the first time, or there's a lot of blame inside the company for why customers aren't receiving what they get. After the seminars or after the webinar is over, Mary-Eleanor will send you a 14 symptom list of symptoms of a broken process, and you can use that to assess one of your own processes and start a really interesting conversation inside your world. Certification training. We at Dell offer certification training. We offer it face-to-face, and starting this fall, starting in November, we're going to be offering a blended version of it that has live online classes on Mondays from 2:30 to 4:30 p.m. Reading assignments, videos, online quizzes and assignments. And me as your facilitator, and I really look forward to this. It's going to be super exciting. Normally we offer this in classroom face-to-face for three-day modules, so 9 days of classroom training. So this is a new way that we're going to be doing this, that I think in addition to responding to COVID, we'll also respond to work schedules that are far more amenable to 2 hours a week in class rather than 3 days at a time. And we do have group discounts and in-house programs available. If you'd like to know more about it, please click on this link, and perhaps Mary-Eleanor will share that with you when she shares the symptoms of a broken process with you. And if you have any questions, I would love it if you would get in touch with me. Feel free to jot down that email address, and I would welcome your questions through email after the seminar. I also welcome them now, so if any of you have questions that you'd like to ask, fire away. Please open up your chat, and I'll open up my chat, and we'll get those questions answered. So thank you for paying attention and listening and joining so far, and I look forward to answering your questions.
Thank you, Angela. And yes, feel free to add any questions in the chat. We only have a few minutes left, and so as Angela said, we will be sending out an email later today with a link to the recording of the webinar, as well as the checklist that Angela mentioned, and we will also have her email address included in that email as well if you'd like to get in touch, and perhaps if we aren't able to get to your questions today. So we do have just a question from Diane here in the chat. What is a realistic time frame for process improvement? I realize that it depends on the length and complexity of the process. Can you speak to timeframes? And just before we do that, Angela, I just want to make sure for those who are able, who aren't able to hang on and listen to that response, I would ask that once you click away from today's webinar, that you please fill out the 5-question survey that we have. We'd love to get your feedback and share that with Angela. And so over to you, Angela, to answer that question.
Well, Diane, you're absolutely right. It does depend on the length and the complexity of the process. It can also depend a bit on how experienced your organization is at doing process improvement. It is very realistic in an organization that starts to get used to these types of processes or projects and picks a process that needs to be sped up but doesn't have a huge amount of quality problems. Some of those can be done in as little as a month. A typical time frame is 2 to 6 months of part-time work. So working about 4 hours a week for about 2 to 6 months, you can generally finish a process improvement project with the full Lean Six Sigma toolkit. You will need to have a small team of people that support you. Also, they'll be working part-time, generally about 2 hours a week. That's my best description of a typical time frame.
Great.
Thanks for the question.
And we have another question here from Eutheny. What is the difference? Can you speak to the difference between a green belt and a black belt?
Sure. You might have heard at the beginning of the webinar, I'm a black belt, and the course that we have at Dalhousie is for training green belts. Green belts have the equivalent of 2 weeks of training in statistical analysis, change management, qualitative gathering, data gathering, and improvement tools. And they are qualified to lead projects within their organization that will reduce quality, speed, and cost, or increase quality, sorry, while improving speed and reducing cost using the DMAIC methodology. However, every once in a while, tricky stuff comes up, and also green belts are typically a little bit newer at it at first. So there's an expert function called the black belt, which has, and black belts have the training and skill set to deal with more complex projects or statistics that occasionally get a little bit more complex. So you've got someone to go to help you navigate the toolkit and to deal with the tricky bits. I think that's the best way to put it. Black belts also train green belts, and black belts in an organization typically work full-time on process improvement, not just in addition to the work that they have. Thank you. Any other questions?
There don't seem to be any other questions that I see in the chat. Yeah, and then a few people need to run, I think, to other meetings. So why don't we end there, Angela? And as I said, I will provide Angela's email address in the email that we will be sending to all of the participants today. And thank you so much again, Angela. Really appreciate your time and your expertise. And thanks very much, everyone, for joining us. And we look forward to you exploring this course and seeing if it's a good fit for you. So thanks very much again, and feel free to fill out the survey. Thanks.
Thanks, everyone.
Take care.